And welcome, ladies and gents. It's Mr. Callan coming at you with the objective for today. I will solve addition and subtraction one-step equations using algebra. Now, to review where we've already been with equations, we kind of in the red down at the below, we have discussed 4 plus 3 is equal to 7, same amount of money, $4, $3, $7. 2 plus 1 is the same as 1 plus 2. The blue, x plus 114 equals 237, that's where we're starting today, so that we can take it a step further. Both of those things will happen this year with two-step equations and multi-step equations. You will see multiple x terms. You will see an extra term with an extra number that we will want to solve. Now, a reminder, please, that algebra is really just brain lifting, is what it is. So if I were to give you these, why don't you go ahead and pause if you wish, come up with a couple of these on your own. If we wanted to figure out what these were, 15 plus what is 24? Well, we would have to go up 9 in order to make a true statement. And that's what an equation is. It's a statement in which both sides are equivalent, the same, equal. For the one to the right of it, you would have to start at 96 and then go up 4 and then 10, or 14, to get to 110. For the red, for the yellow, let's do the yellow circle first. We have to be above 76 if we're going to go down 6 to get there. So we'd have to start at 82. For the hexagon to the right, you'd have to go down 35. For the red box, the red square, what would make a true statement? Well, we're starting higher than 13, going down 24 to get there. We would have to start at 37. And then, of course, we have the pink arrow. We'd have to start at 24 to get to 12. I feel like you guys have done okay using your number sense and computation skills, but look, it's going to get harder. What if instead of 24, that said 24,000 and 2/3? And that said 12 and 1200ths. We need to be able to learn how to communicate our algebraic steps for when the numbers and the equations get tougher. That's what we're focused on today. Now, to show you one brief example, every equation can be kind of like a scale if you think about it. If you think about these being dollars, we got a wallet, a blue wallet with X dollars. And then we got 5 more dollars. And it's the same or equal or equivalent. Notice that scale is nice and balanced to $11. Now, what we would like to do is to find out how much money is in that wallet without the $5. But you cannot just magically take $5 away, or the whole scale would tilt, which we don't want it to do. So anytime when you're talking equations, you might remember this from 6th grade, anytime you take away 5 from one side, you must be fair quickly and take away 5 from the other to maintain equivalency. Oh, look what the scale says. The scale says that that amount of money in the wallet, that X must be the same as $6. To write that algebraically, this is just an example, just follow along. What we do is we write with numbers and symbols the same thing that we just did with the picture. So we have X plus 5, let's take away 5. You see I put it in red right there. 11, take away 5. And then, oftentimes I will invite you to cross off the plus 5 and the minus 5. You see it here, there's nothing left in the picture. And I'm not going to ask you to write X plus 0 equals 6. There's no need, there's no reason to write that 0. Now you see this little check here because frankly, we should be able to check our answers all the time. That means anytime you have a quiz or a test with an equation, you should be able to check yourself and you will know if you're correct before the teacher even gives it back to you. When I substitute 6 into the unknown, 6 plus 5 is in fact equal to 11. Oftentimes, I will even write the word true underneath, although some people put a check mark. So I want you to, every time we talk about equations, I want you to think about a balanced scale. And remember, anything you do to one side, you must maintain that balance and do it to the other. Now go ahead, pause your paper, but listen, pause your paper, pause your video, huh? Make sure you titled this new assignment correctly. We're going to have assignment number 4, solve plus and minus, solve addition and subtraction equations. And why don't you go ahead and underline that. Up here in the top right-hand corner, put your name, the date, which obviously is not the 23rd of 2018, and then hour 1 or hour 2. I'm not going to give you the assignment just yet. I want you to watch the rest of the video, but pause, title your paper first, name, date, period, assignment number 4, plus and minus equations. And we're back, so let's go on. Before I give you the homework, let's just pause and look at a few of these. In fact, if you wish right now, you can pause and look at these examples, but we should be able to write and solve an equation for the following examples. Now let me just focus on writing the examples. If I were to look at the left side, the left example, I see some unknown amount with an extra 3. And over on the right side, it is the same or equivalent or nice and balanced with 7. Now let's go ahead and solve. Remember, what we'll want to do is we'll want to get rid of or eliminate 3 of those. But it's not fair just to do that to one side. We'll also want to do that to both sides. So in my picture, I cross off 3. And down on my steps, I go ahead and write subtract 3 from both sides. Now remember, I'm asking you to go ahead and slash off the plus 3 and the minus 3 because those make 0. Those are no longer there, which means on the left side, we only have x remaining, and on the right side, we have 4. But let's always check the equation. In this case, 4 plus 3 is equal to 7, and I'm going to go ahead and write a true down there. Some of you might write a check mark. There's one example. Let me give you another. If I look at the equation on the right, I'm seeing here, all right, we have a fair balanced equation. We have 1, 2, 3, 4, 5, and 6 is 11 on the left side. And it's equal to some unknown amount plus another 2, 4, 6, 8, and 9. Now, let's go ahead and let's get rid of 9 of those. So I'm going to get rid of 5, 6, 7, 8, 9. And we're going to write that algebraically as well by subtracting 9 from both sides. We go ahead and say 9 and a negative 9 makes 0. Ah, beautiful. That means the only thing remaining is x. And I tell you what, I should have written x is equal to 2. But notice that's an equivalent statement. You can write x equals 2 or 2 equals x. I would accept either. Don't forget to go back and substitute 2 into the equation. Is 2 plus 9 equal to 11? Well, sure. 2 plus 9 is 11, and that looks the same as 11, and so that is a true statement. And remember, with videos, you may pause. You can rewind if you want to watch something again. You can skip forward if you wish. Let's keep on rolling. First thing, let's go to the example on the left. If we have some amount with another $21 and it equals 34, what would the first algebra step be? Well, in order to get rid of the plus 21, the extra $21, we would want to subtract 21. And so then we can slash off plus 21 minus 21. And in this case, x is equal to 34 take away 21. X equals 13. Now we go ahead and we substitute 13 back into the equation, and we're going to add those together. 10 and 2 tens is 3 tens, 3 ones and 1 1 is 4, and that looks to be a true statement. Ladies and gents, when you get to your homework, I will fully expect you to have every single step written out. The problem, the algebra step, and then your final answer. You probably want to circle it, as well as the checking, folks. You need your checking as well. Let's take a look over on the right side. We have x plus 15 equals 37. So how do we get rid of that plus 15? Which of those algebra steps will best help us? Well, to get rid of the $15, we'll have to take away, and of course, we'll have to take away 15 from both sides. I could just point out down here, plus 15 does not cancel out to make 0. That would just add more dollars or more weight on both sides of the scale. All right, so how would we solve this equation? If we were to go ahead and subtract 15 from both sides, 15 and a negative 15 make 0. And so we now have x equals 22. We're going to substitute 22 back in, add those together. Is this a true statement? It sure is a true statement. Those are some examples that you might have written. But on the other hand, what if we have a scale of, well, in this case, it's interesting. We have an unknown amount, but we also have minus 9. Now picture 47 over here, $47. So minus 9, instead of weighing the scale down, might actually lift it up. I don't know. So maybe it's a balloon. It's balloons. So we got to get rid of those balloons, right? But how do you get rid of minus 9? Well, in this case, to get rid of a minus or a negative, you would need to add 9 to both sides. So think about it this way. First of all, you do see the plus 9 being fair to both sides. You also see that minus 9 and plus 9 make 0, and we have our answer. In this case, we think x, the unknown amount, is $56. Now let's check this out. If we were to substitute 56 back in there, 56 take away 9 is 47. Yep, Mr. Cowan, looks like a true statement to me. Let's follow that logic with the example on the right. How are these problems the same? Well, they both have an x. They both have a minus sign. They both have equals. They both have another number on the right. How are they different? Well, the numbers are different, Mr. Cowan. We have minus 9 minus 51 equals 47 equals 33. But how can we use what we just learned on the left? Well, to get rid of that negative 51 balloons, that negative $51, let's add the $51 back in. But we must, of course, be fair to both sides to keep it fair and balanced. Now, a minus 51 and plus, hey, that's good. That all cancels out. That leaves us with x equals, in this case, before the $51 was taken out, there were 84. But let's check it to make sure. If we substitute 84 in and we take away 1, 1, and 5 tens, hey, that looks like a true statement to me. Again, you will notice your steps. Write the problem, write your work. May I suggest circling your solution? But yes, folks, you need to check your work. Every problem on this assignment this evening, I'm asking you to check your work. Let's do another couple real quick. How do we get rid of my, actually, if you want to, pause real quick and I'll do these rather quickly. In order to get rid of minus 34, we're going to add 34 to both sides. So let me get rid of these and these. Now, when you add 34 to both sides, a positive 34 and a negative 34 will cancel out, leaving us with x equals 100. And when you check, you will find a true statement. I write true, many people write a check mark. For those of you that went on to the next problem, how to get rid of minus 14? Well, of course, we're going to add 14 to both sides. When you add 14 to both sides, a minus 14 and a plus 14 cancel out. Oh, well, of course. Most of you had the number sense to figure that one out without even the algebra steps. But I have to challenge you. Remember, we're moving into two-step equations, multi-step equations with lots of x terms and decimals and fractions. You need to write your algebra steps, even if it's obvious. Go ahead then, let's check our work. Is 14 minus 14 the same as, oh yeah, you bet that is. It is a true statement. So with that in mind, I'm going to invite you now to write the page and the numbers, page 17, numbers 31 to 36, 49 to 52, page 19, numbers 32 to 37, 46 to 51. Here's what you do not want to do. Do not number your paper 31, 32, 33, 34. Bad idea. Because every problem, and don't write this down, I don't remember what the real problem is, you will have to write the equation. You will have to write your steps. Subtracting 3 from both sides. Again, don't write this down. This is not the real number 31. You will have to find your answer. And then you will have to check. Is 7 plus 3 the same as 10? Oftentimes, I used to put a question mark over that equal sign. So you see that every problem will take 4 or 5 lines. Do not just number your paper 31 to 32. Hey, you know I'm going to be checking your numbering, so make sure you have the page titled correctly. Assignment number 4 should be written at the top. Solve plus and minus equations. Name, date, and hour 1 or hour 2. Page 17 in the numbers, page 19 in the numbers. Then you may begin. Maybe you wrote an example or 2 down. If you wrote an example or 2 down, whatever your examples are up here, I've seen some students draw a squiggly or a dashed line. You probably want to do that because this could take more than 1 page front and back. We shall see. One last thing to leave you with, I wanted you to know in class, coming up is going to be a quiz, as a matter of fact. I don't know if it'll be the next time I see you or the time after. But then I'm going to hop you to assignment number 7, solving non-routine problems. This is kind of an in-class thing, so I really want you to do this with a partner, but I'm not sure I can figure out a way to do it with social distancing. We shall see. I just wanted you to know, not only will you have those other problems, but we'll be doing pages 12 and 13. And from numbers 1 through 7, I'm going to have you pick 5 of those 7 problems. And again, no promises. We'll see if we can do it with a partner or not in a safe manner. All right, folks, hit me up with an email if you need. No need to go on to start the assignment, but I know some of you want to. Just make sure that you have the page numbers and the assignment title at the top. Don't forget to write all your steps. And check your odd answers in the back of the book now that I've taught you how to do that, okay? All right, we'll catch you guys soon. See ya.